Hi everyone, so hope you are doing great in your life. So today this is a tutorial for beginners who is using Zynq SoC in first time. So Zynq SoC is system on chip. So basically we have everything UART, SPI and ADC inside of that FPGA in the same silicon dia. So in this video we will see how we can use the FPGA part and the processing system that we call that SoC part, how to integrate both the things and how to use the that FPGA. This is a basic tutorial for that. So let's see how. So today I'm gonna use this PYNQ Z2 board. You can use any Zynq based SoC board. The only difference will be you have to use your own board files and all. That you can go to any YouTube video and how to integrate and how to download and add those board files. So the main agenda of this video to print the hello world using this Zynq SoC. I'm using PYNQ-Z2 again. So let's start this. So this is a reference manual for PYNQ-Z2, but in this reference manual that you will get online, right? But in this reference manual, I've seen this links that they have provided for Zynq S2 boards file can be downloaded from here, and the master constraint file also downloaded from here, but it is not working. That is fine. I have found other links that are official links from Zynq GitHub. This is the Zynq one, and in this you just have to download this master file, and then this is a step I'm telling you how to install or how to add the board files. Then you have to go to this boards, then TUL. In the TUL you will see these two boards files are there, Zynq Z1 and Zynq Z2. Right now I'm using Z2. It depends upon either you are using Z1 or Z2, or either you are using any other artic file, artic board for that, ultra scale, whatever that is. This is a SoC file, master, or not SoC, sorry. This is a constraint file, XDC file for that Zynq Z2 board. This both the links I will provide in the description. But in today's video we will not use this XDC file, but later I will make one tutorial as to how to use the NAND gate or how to make a full adder using combining the programming logic and processing system part. That is a part of different things. So let's start. So in Vivado, okay, first I'm telling you the steps. So you just have to download this library. You just have to download these two files. You have to paste where. You just go to your C wherever your Zynq, wherever your Xilinx is installed. So I have installed two versions. This is different version 22. Today we are discussing on 2025 because that is the main problem. Right now I'm also facing the difficulties how to make it work because no YouTube tutorial is there related to that. So in 2025, again go to Vivado, and whenever you will go to this data folder, in the data folder you search for boards. This is the board folder, and then this folder might not be there, board underscore files. So if it is not there, then you have to create this folder. If it is there, that is fine. And here you have to paste those board files. So this is Z1 and this is for Z2, that is fine. So let's start with the Vivado now. And today we are going to use Vivado 2025 and Vitis 2025, that is Vitis Unified IDE. And no YouTube tutorial is there. So that is why I'm making this new one. So let's start, create new project. Create new project. I will name it hello YouTube. Then RTL, always RTL. No need to create this source file. No need to add this constraint file. Okay, fine. I'll just go to my boards. This is my board Zynq Z2. That's what I have added. You can use ultra scale. You can use RTX or whatever Zynq based SoC. Next, finish. Let me check the recording is going on or not. Okay, it is fine. Now today we are going to use the block diagram itself because most of the time we will use the block diagram itself whenever we have to use the processing system, because in the coding part it will be very difficult. Then later tutorial I will tell you how to integrate the RTL and the block diagrams. So I will just name it design 1, that is fine. We'll wait for some time. It will not take more time as I have i7 processor over here. Let's go. So you will go to this add icon, and first we will integrate the main Zynq SoC. So what is that name? ZYNQ7. This processing system you can see over here. You just add it. That is fine. if you just go inside of this, you will see how many parts are there, which one you have to use or which one you have to dismantle, not dismantle, which one you have to ignore. Like this, you can turn on, turn off anything. But right now, you can turn on anything, you can turn off anything. That is not a problem. We are not worrying about. The main thing is this UART ports are working. UART port has to be work because we are using. We have to use the serial or UART thing to print that hello world. Here you can see all these memory interfaces are there, peripheral interfaces, whatever is working or not. So let's just check UART1 and UART2 both are working fine, and no need to other things. Okay, now it is fine. Now one more thing we need for this thing, for a clock also we need. So clock, we will use one block that is called reset processing element, processor system reset. Yeah, this is one, this is that one. You can manually also collect this clock to this slowest clock and other this reset and all, but we will run this block automation. Make sure to tick this thing, and this fixed DDR, fixed input output and DDR is there, that is fine. Okay, run. Now run connection, will connect everything. Slowest clock already we have connected, no problem. Then external resetting, that is also connected, fine. So this is our block diagram. You will just save it. You will also go to here, validate, validation successful. If there is no error, if there is any error, you will get to see, and you can follow any tutorial. Don't use the chat GPT for this, how to solve this problem. You can use the community itself, that is more helpful than chat GPT and all. So now once it's done, now we have to make a design wrapper. We have to make a Verilog code for this block diagram. How we will make? Again, you go to this thing, Explorer. In your design sources, this is your block diagram, .bd. BD is block diagram. Right click on it, create HDL wrapper. Let Vivado manage everything. It will not take more time. Now it will write a Verilog code automatically based on this whatever we have used. So if you just go to this thing, here we have used this board, and again this is what we have used. This is the Zynq SoC. This is that reset block. Everything is connected to 0. That is fine. Don't, we are not worry about this thing. We'll close everything. This is our block diagram, fine. Now we just have to generate a bit stream for that. Again, I'll go and generate a bit stream. Number of jobs 10 maximum, fine. Now it will take some time, 2-3 minutes. So I will pause the video over here. Okay, so I'm new in this Vivado. I don't know how to pause it. Okay, fine. It will not take more time. It is already running. For the meantime, I'll tell you some tips related to the Zynq SoC. Whenever you're programming this thing, make sure your this J1 jumper, GPI jumper, is connected to the JTAG one. If you are connecting to Q SPI or SDE, then it will not work. So make sure it is connected to the JTAG one, and then you have to power it through the USB only. No need to power it to that USB DC jack. And the rest, no need of memory card also over there. We are not booting the system. We are using right now this Zynq board as a FPGA part. Fine. Next, rest no configuration are required. Make sure your USB support UART communication, and then okay, rest I think that is enough. Run successfully completed. Running synthesis. Mm, mm, mm. As I'm new to this thing, I don't know how to pause it, but yes, you can skip here sometime. Synthesis is already completed. Okay, so now bitstream generated successfully. We can open this design also. You will see we are not using any LUTs, anything. We are just using this Zynq SoC. And yes, we are using the LUTs for the UART purposes. Let's see how it is there. We will not waste more time over there. So this is the Zynq SoC. This one part is the SoC and rest is the FPGA. So this part we are using over here. I don't know why we are using this. Unbounded, unbounded. Maybe for that UART purposes itself. This is the main Zynq SoC. If you zoom it over here, then it will. Okay, this is the main. No need to see go to all these details. But this complete section is the Zynq SoC. Rest part is the rest part is the programming logic. This is the processing system. Rest is the programming logic. Everything is inside one dia itself, one silicon dia. Now, once your bitstream is generated, you have to go to this file option, export hardware. Next, include bitstream, don't include the binary one, include bitstream, design one wrapper, that is fine, make sure your location is same only, next, and then finish. Now it will generate one .xca file, that is the hardware file that we need in the invert in that Vitis environment. Now directly I'll open the Vitis from tools, Vitis IDE. So I'm using both. This Vivado is also 2025.1, Vitis is also 2025.1, and no YouTube tutorial is already there as I have discussed already. Okay, so this is open now. We'll wait for it. Now you have to go to this part, create. First you have to create a new platform. Before making any application, we'll create a new platform. Create new platform. Done. Here you can change your same project, whatever project we are making. For example, we are making Hello YouTube. Change the directory. You can name this platform also. You can rename it also. I'll not change the name. Hardware design. In this hardware design, you have to select that file. Again, I will go to that same folder. Go in Hello YouTube, and this is my .xsa file. Design one wrapper.xsa. I will select that. Next, it will automatically select the operating system and the processor based on the board that you have selected in the Vivado. Compiler is GCC as we are using the C programming over here. Next, summarize this one. Okay, fine, finish. Now also it will take some time. You have to wait 2-3 minutes. It will not take more time. Update the workspace. Fine, update it. No problem. Here down here you can see the process is going on, and no need to work whenever this process is going on. You have to wait, otherwise your changes will get again affected, and it will not get affected. You just wait for it, and it will show a notification in the right bottom like this. Created platform successfully. Once your platform is created in the Explorer, Vitis Explorer, you can see only this platform is there. No need to change anything over here. Now in this platform, we will link this platform to the one application. That application is that hello world, right? So click new component application. Okay, no application. That application you can directly go to, click new example, fine, and then this where is our hello world. This is hello world. Just click on it, create application component from the template, hello world, fine. This location is same. Next here you have to select that platform, whatever platform you have already created, right? Whatever name that is. My name is platform itself. Next, it will take the same settings from there. No worries, finish. Now also it will take some time. Let's wait. And once it's created, you will see here with the platform we have one hello world program. We have a hello world folder. Inside of this folder we have multiple things of how many libraries we are requiring, we are using, not we are using, this is the initial libraries. Fine, we will not waste our time over here. Directly go to the output, not output, sources, main hello world, fine. So here you can see our hello world is there. So it is giving some error. I don't know why it is giving the error. You can skip this thing. How? Just uncomment this thing, and instead of print you can use the printf. That will work fine. But one more thing, this is the library that is updated by the Xilinx itself. So if you have to update this library automatically, you just go to this platform once here in the component, make sure the platform is selected, just build it once, then it will automatically add these libraries. Then you will see this error will go. We'll just wait for it. One other method is you just use the printf function as Python or as C programming. It will also work. Okay, now it is already there. We have already built platform build finish done. Now again you will go to this hello world. Hello world is there. Again we will try to build it. Build finish successful, fine. And here now you can able to see that error is already gone, and this file links, this library is already added. No need to worry about that error. Once your build is completed, it will show the tick over here. No need to change. Okay, we can change this hello world successful hello. I'll update this to YouTube. Fine. Save. Again I will build it, and now you have to connect your that FPGA part. Now I will connect that FPGA, my Zynq PYNQ-Z2 Zynq SoC based FPGA. Once it's connected, build is successful. Now you will go to this Vitis program device, and whatever bitstream that is generated over here, it will automatically select the Zynq wrapper.bitstream. Auto detect, fine, no need. I'll just program it. You will see here programming the device. Now we are burning that bitstream in the programming logic that is in the FPGA. Program device finished. Already we have programmed that FPGA. Now we have to run this this hello world, right? So we have to see this terminal serial monitor, right? So in that Vitis itself we have one serial monitor. I'll connect this serial monitor. This is my board COM4, and the baud rate over here you can see it is already default 115200. I will select this one only. Fine. Now I'll just reprogram it, not how I will run this C program, that is hello YouTube, hello run world application, hello successfully run hello world application. Let's see. Okay, in this communicate in that COM port you can clearly see hello YouTube successfully run our hello world application. So now this is our video of whole video of this. No need to show the FPGA because there is nothing over there. You can directly go this complete Vitis and unified is almost similar to that Vivado, sorry, VS Code environment. We can rerun it also. We can debug this line by line. We can see the register values over here, how much memory and everything is affecting. And it is not a part of this video. That is, we'll cover this thing later. Again, you can see hello world application successfully run, completed. Again I can see here hello YouTube successfully run. So that is it from my side. If you have any doubt you can message me anytime. Not message, yes, you can comment anytime, and later on I'll make a complete video how to use the SoC part. That means how to use the processing system and how to connect the processing system with the programmable logic, that is the FPGA. That is it. Bye for my side. Peace.